Welcome. This is our Teach07 design pattern on the adapter pattern for CS364. It is by James Harris, Jeremy Griffiths, and Anthony England. In this presentation, we will go over what the adapter pattern is, how it relates to our family finance application, the upsides and downsides of using it, and some recommendations of when to use it.
The concept of an adapter is something we are all familiar with, and most of us use in our everyday lives. For example, currently I have my cellular phone plugged in and charging. The phone uses DC power, which is supplied by the charging cable. At the other end, it plugs into the wall, which is providing AC power. This charging system is an adapter, both physically and electrically. It has a micro USB connector on one end and a two-prong connector on the other, allowing systems with different connectors to connect with one another in a useful way. The other thing that is happening is the AC power from the wall is converted to DC power that the phone can use. Data can be provided to software in many different formats. Oftentimes this is a format that the software is unable to use. Therefore, it's important that the software be able to convert that data into a format that it is able to use. This is where we use the adapter pattern. It converts the interface of a class into another interface the client expects. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces.
There are many places that the adapter pattern could be used in our family finance app. We will be focusing on the external interfaces requirement that states the system shall allow automatic income and expense tracking by linking all of the user's accounts. Here we have a simplified example of how the adapter pattern could be used in this requirement. The UML class diagrams show the three parts of the adapter pattern. They are the client, the adapter, and the target. In this example, the client expects to interface with the target, in this case, the target account, a specific way. Because a target account will be a third-party account of the user, we will not have control over its interface, and it is possible that its interface will change in the future. There are also different kinds of accounts that will be linked. They will all likely have different interfaces from one another and from what the client is expecting. In order to bridge the gap between the interface of the target account and what the client is expecting to interface with, a target account adapter is created that implements an account adapter interface. This allows the client to interact with all accounts through a single interface. A target account adapter has a target account. This allows it to interact with a target account while still giving the client what it expects. Because the client interfaces with an adapter instead of the target directly, only inside the adapter will need to be changed when the target's interface changes. This is one example of how the adapter pattern could be used in our family finance application.
There are several advantages to using the adapter pattern. One advantage is that it uses object-oriented design principles. The use of composition allows the adapter to easily add the functionality of the adaptee class. This also adds the benefit of being able to use the adapter with any of the subclasses of the adaptee, so one adapter can be used for several adaptee classes. The adapter pattern also binds the client to an interface instead of an implementation. This means we can use several adapters that each convert a different backend set of classes, or we can add new implementations after the fact, as long as they conform to the target interface. Another advantage is that it promotes reusability. Many companies have legacy code. This code can still be used in a modern environment. An adapter can be created that makes it so the previously incompatible interfaces can communicate. It also provides a great deal of flexibility. An adapter can be used both ways. A two-way adapter can act as an old or a new interface, so that the interfaces can communicate with each other in both directions. There are also some disadvantages to the adapter pattern. One disadvantage is that the adapter can become quite large if you are supporting a large interface. The job of implementing an adapter is proportional to the size of the interface you need to support as your target interface. Even though having a large class for the adapter can be hard to work with, it is probably easier than having to change all of the client-side calls to match the interface, which would require a lot of investigative work and a lot of code changes. The adapter provides a way to encapsulate the changes into one class rather than having the changes made in a lot of different places. Another disadvantage is that using adapters can create a rabbit hole situation. If you are not careful, you can have an adapter that calls another adapter, that calls another adapter, and so on. This can make it so it is hard to trace where all of the calls are going, which makes it harder to test your code. The extra calls also add overhead costs, so your code will run a bit slower than if the calls did not have to go through adapters.
Going back to the phone charger, it makes sense to create an adapter for a phone charger. This allows AC power to be converted to DC power. If we didn't have this, all phones would need to be replaced with ones that can be charged with AC power directly, or the entire power grid would need to be changed to supply DC power. When trying to decide whether we need to create an adapter, we need to ask three questions. Does one interface work with all vendor and client software in all situations? 2. Can we rewrite our software so that it does? 3. Is the client or third-party vendor willing to replace their system so that it is compatible with our interface? If the answer to each of these questions is no, then we need to build an adapter.
This has been our presentation on the adapter design pattern. Thank you for watching.